This is part 5 of the derivative notes. This is about the power rule, the shortcut for finding the derivative of a polynomial. Yesterday in the notes, you'll recall that we derived the formula for the derivative function for f of x equals x squared and f of x equals x cubed. And we found that f of x equals x squared has a derivative of 2x, and f of x equals x cubed has a derivative of 3x squared. Following that same pattern, we could look and see what is the derivative of x to the fourth. Some of you may think, if I follow the pattern, that looks to me like that would be 4x cubed. Others of you may still be scratching your head and not knowing where I got that, but I'll explain in a moment. If f of x was x to the fifth, f prime of x would be 5x to the fourth. You starting to see it now? Look what you might notice here. The exponent becomes the coefficient, and the new exponent is 1 less. So 3 becomes the coefficient. I go from an x cubed to an x squared. 4 becomes the coefficient. I go from x to the fourth to x cubed. 5 becomes the coefficient. I go from x to the fifth to x to the fourth. So in general, we can say that the power rule tells us that the derivative of the function x to the n is n times x to the n minus 1. So we're going to look at a few examples. What happens, though, if we already have a coefficient in front? This isn't just x to the fourth, it's 3x to the fourth. Well, think of it as 3 times x to the fourth. Find the derivative of x to the fourth and just multiply it by 3. So f prime of x is just 3 times 4x to the third, which is 12x to the third. Another way of looking at that, maybe in a more concise way, would be take 4, the derivative, multiply it by the coefficient that's already there, which is 3, and then just reduce the exponent by 1. So we have 4 times 3 x cubed. Now, this is an interesting one. What is the derivative of 4? Well, we have to, if we're going to apply the rule, we have to think this, what is the x involved here? What is x in here? This would be 4x to the 0 power. Well, if we multiply 0 times 4, we just get 0. So it really doesn't really matter about it. Technically, it'd be 0x to the negative 1, but it's just 0. So f prime of x is equal to 0 here. And what we can say is that the derivative of a constant is always 0. Now, why is the derivative of a constant 0? I think it'll make sense to you if we draw a graph. Let's draw a graph of f of x equals 4. That's the same thing, of course, as saying y equals 4, which is just a horizontal line at y equals 4. What is the slope of a horizontal line? At every single point on that line, the slope is 0. Slope equals 0, which is why the derivative equals 0. Because the derivative is the slope of the line tangent to the graph at any point, and the line tangent to this line would be this line. This really can't make a tangent line to it, but the whole line just has a slope of 0. Now, what about if we have a polynomial with numerous terms? Well, all we do is we apply the power rule to each of the terms individually and just add them up. So f prime of x is equal to 3 times 4, 12, x, lower the exponent, squared, minus 2 times 5, 10, lower the exponent to x to the first. 1 times 2, which is 2, lower the exponent to x to the 0, which means there is no x value now. It's just x, that's a 1. And then the derivative of 7, which is a constant, is just 0, so that's our derivative function. 12x squared minus 10x plus 2. So repeating that again, you might want to try this one on your own. Pause the tape right now. Write the derivative function for f of x on number 4, and then turn it back on. Hopefully, this is what you got. 15x to the fourth minus 12x squared plus 1. Now it says find f prime of negative 2, which just means plug negative 2 into the derivative function. So f prime of negative 2 is 15 times negative 2 to the fourth minus 12 times negative 2 squared plus 1, and that equals 193. Check it out. Are you impressed by my lightning fast ability to compute that function? No, it's just because I have it memorized. Having done this, taught this in class 3 times today, I just know what it is. It's 193. What does that number 193 tell us? So I want you to think back to previous notes. 193 is the slope of a tangent line. The slope of a tangent line to what? To the function f of x. Where is that tangent line located? At the point negative 2 something. So let's just write this. The interpretation of what 193 means. First interpretation, that 193 is the slope of the line tangent to f of x at x equals negative 2. So that means when the graph, when we're looking at that graph, when x is negative 2, that graph is very steeply sloped in the positive direction. Number 2, what another interpretation of 193 is the instantaneous rate of change. Now the reason we use the word instantaneous is that rather than a line, which is a constant rate of change, or rather than finding the point between two lines, which is the average rate of change, instantaneous rate of change is the rate of change at specifically one point on the graph, because a polynomial curves, so every single point on the polynomial has a continuously changing slope. So this is the instantaneous rate of change at x equals negative 2. So those are two different ways to interpret what the derivative means. That's what that number 193 means. Okay, next problem. Let's once again find, it says find x when f prime of x equals 0. So we need to start out by finding f prime of x. So once again, you might want to turn off the tape, try it yourself, turn it back on. F prime of x, negative 2x plus 3. This is a pretty simple one. Now it says find x when f prime of x equals 0. And you say, that's easy, that's 3. No, it's not 3, because what you just found was f prime of 0. I didn't say put 0 into the function. I said set the function equal to 0. In other words, I want to say 0 equals negative 2x plus 3. So 2x is equal to 3, x is equal to 3 halves. Now the next question asks, what feature on the graph did I just find? Now specifically, now if you look at the graph, if you're thinking of the graph of f prime, you found the y-intercept, but that's not what I meant. I probably should have clarified this. What feature on the graph of f of x did I just find? So here's my function f of x. Notice it is a parabola. Because it has a negative sign in front of the x squared, it is an upside down parabola. So it's a parabola that's doing like this. I just set the derivative function equal to 0 and got 3 halves. So what does that 3 halves tell me about this function? Well, hopefully you recognize that it's going to tell me the vertex, because the vertex is where the slope equals 0 and the derivative is the slope of the tangent line. So with a tangent line at the vertex equals 0. So that means I could draw a sketch of this graph. I know 3 things so far. I know that it's, well, I know it's 4. I know it's a parabola. I know it's upside down. That's 2 things. I know it has a y-intercept of 4. And I know that its vertex has an x-coordinate of 3 halves. So if this is 1, 2, and 3, 3 halves would be about right here. So somewhere up here is the vertex. I don't know exactly quite how high it is, but I'm just going to kind of sketch it. It's going upside down like this. So this is the point 3 halves something. Now how would I find the y-coordinate of the vertex? Amazingly enough, I just plug x equals 3 halves into the original function and I can find the y value. And that turns out to be 6.25. Once again, not an amazing computation, but merely remembering what I've taught several times already today. So this is 6.25, which looks very reasonable with the way I sketched the graph. So what I found was when f prime of x equals 0, x is the x-coordinate of a vertex. Now, a parabola happens to have one vertex, but we're going to look at an example. You know, that looks like all one word, so I'm going to change that a little bit, sorry. And I need to scroll up a bit. Of a vertex of f of x. Okay, it's a vertex of f of x, not a vertex of f prime of x. Now the next graph happens to have two vertices. It has one here and one here, and I'd like to be able to find the coordinates of that, neither of which are going to turn out to be nice numbers. So first of all, start by finding f prime of x. So f prime of x in this case, 3x squared minus 26x plus 52. Now, at these two values, remember, the slope of the tangent line is going to equal 0, which means the derivative function has to equal 0. So I'm going to set f prime of x equal to 0. So this is what I'm trying to find. So 3x squared minus 26x plus 52 equals 0. And I need to find an x, the x's that make that true. And notice I'm going to get two values for x, which makes sense because I have two vertices now. You will need to use the quadratic formula for this. So let's sing. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And don't forget that the a is actually a 3 here. We're so used to writing 2 times 1, but it's actually a 3. And I'm going to pause a moment and calculate those values. You'll want to do that on your calculator. You can just get decimal equivalents. That will be fine. Okay, well, after you've done the quadratic formula, you'll see that x is equal to 5.3535 or 3.131. That's what you should have gotten, and that makes sense because you can see the 3.13. That looks really reasonable for the x coordinate of our vertex here. And the 5.535 looks really reasonable for our x coordinate there. And if you then plug the two x values back in the original function, this is our original function f of x here, then you can find the y coordinates of those points. And those also look reasonable. So this is 5.535 comma 26.06, which we estimated the first day to be about 26. We were very close. And this is 3.131 comma 20. Oh, this is the, I just did those backwards. Sorry. Backwards, backwards, backwards. This is 3.131, 26.06, and the other one is 5.535 comma 19.12, which also looks really reasonable, just being a little under 20 there. So this is how you find extreme points. Your homework then will involve finding tangent lines, extreme points, and extreme points being another word for vertices, using the derivative function, which you find using the power rule. So make sure you know how both to calculate the derivative and to interpret it once you have gotten it calculated.